Alright, this is a video for project part 1, and this is Shane. Okay, so this is going to be a very detailed video, so just in case. Um, okay, so here's the photo for the real part, and we do have the model number if you want to take a look and take a screenshot of photo from Home Depot website. Then the model is here, and okay, let's start a blank file. Put this aside, and all right. So before we start, there's something I have to emphasize again. If you were in the lab, first, the dimensions are not strictly required. If you can't follow the dimension exactly, it doesn't matter, as long as you can put your parts together. So say I have my hose 1 inch in diameter. If you have yours 1.5, and you have to make the other part that goes into this part 1.5 inch, right? Then the method we're using to model this is just one of the methods. You can use all kinds of different methods you want, okay, and we also encourage you to do that. Anyway, so let's go to the model. So first I like to talk about the steps or the idea of the modeling. So basically we started from a sketch, okay, then the extrude into, okay, let's try this. So the first step, a sketch, then extrude, something like this. Then the side, if you look from the side, the top is a little bit thinner than the rest of that. So we made another sketch which is perpendicular to the first sketch, right, as you can see here. Then we extrude that sketch, and when we extruded that, we also use subtract within this extrude to cut this top off if you take a look from the side. Then we did some edge blend for those edges here, and you don't have to use edge blend. What you can do is in the sketch, this corner here, you can make a fillets, okay, like a, and also here you can use the fillets, and then it'll make around the corner as well. So you have multiple, different ways to model parts. Then I used mirror feature to mirror this extrude and the edge blend to the bottom. We look from the side. If you have mirror feature, it'll give you a symmetric cut. And what you can also do is you can mirror this curve within the sketch, and just one extrude, and you have both sides. Then from the top, I did another extrude. This one was because of this edge blend here. Okay, the real thing, or the final shape should be like this, and I extruded extra triangle because this edge blend will not go over this corner. Okay, if I extrude it in the first step like this, and you can avoid that by using a fillet in the sketch, but well, you can try it out if you want to. That's my step, okay. And next is just a couple edge blends to make it rounder. Yeah, this one's here, then the other one is on this side. Given you have the same sketch as mine, and this one is at the tip, okay, and the last one is the big one at the back, on the back. So this will make the bottom of the handle looks like a cylinder. Okay, so this one is a little bit different. This one is a variable radius. By the way, the steps are here. And after that, we can just make this thing hollow using a shell command. Okay, that'll make this uniform thickness like your sheet metal, because the real thing is like stamped or bent by using sheet metal. Then eventually we did two edge blends. One is here, yeah, one is here to make it round, and that's pretty straightforward. The other one is here. Okay, let's start from scratch. Okay, let's turn this off, and a new file, inches, and you don't want to save to that place. And I'm not gonna save, so just to demonstrate. All right, so now I'm just like you, starting from the slides. Okay, and first a sketch on XY plane. Alright, and you can see my origin is there, so I'd like to start from the origin and zoom in. By the way, I uploaded a higher resolution picture in the lab handout. I'm not gonna do that, it's too much time. Okay, so starting from those two circles, and we will give this a diameter, so we know how the scale is right now. See, right now it's that's 10 inches. That's way too big. So if you type in the radius, you can see what level of zoom we're in. So fit, yeah, fit. Okay. Then P8, another circle, 0.6 inch, right? And usually for this kind of geometry, or for any kind of geometry, you want to go continuously from one side. Okay, and you don't want to draw two circles and jump to the bottom, something like that. Okay, so let's use profile tools, and start from here. You want tangent, then we can make a tangent. If it's not tangent like this, you can add a tangent later. We can just try it's not tangent. Okay. And there's a vertical line here, there's something here, and I would stop here, or maybe we can add this reference line also. So that's it. Then I'll turn this to reference. Then we have two holes in the middle, right on another reference line, and that reference line will give us the opportunity to put a dimension there, so you don't have to put two dimensions for those two holes. And if you don't want to see extra under constrained popping up here, you can just add a circle at the end. This way the reference line will have a constrained length. So in my case, this point is not constrained. It can move up and down, and they will say it needs some constraint, but actually the sketch you need is already constrained. So anyway, and I have two dimensions there. You can use constraints, pick those two arcs and make them equal radius. Then you just need one dimension. So different ways, the same results. Then you can drag things around. We can make this tangent. And when you click a circle, be careful. If you click inside the circle, okay, it'll select the center point, that point here. If you select on a little bit outside of the circle, that'll be the arc. So if you want to use those quick constraints, you need to pay attention to where you are clicking on the circle. Alright, and then I'll close this up, and at the same point, okay, So the tangent is on this line because once you cut off this triangle, you will leave this tangent face, okay, to the circle. Alright, then we can probably add some dimensions. So I'm gonna add those horizontal dimensions first, and we're gonna use this y-axis as your reference or dating axis. So everything starts from y. That's a good habit. Instead of like you put P1 here, then you put a distance between those two, because you have y is your reference. So you want your dimension to start from the reference every time. And for more information, that's kind of in the drafting class or Alright, so we have three horizontal dimensions, and we can add those two. Let's see, and you can see as we add the dimension, the color of the curves will change. The green curves, they are constrained, and the red curves are not. So say I can drag those still up and down, but this curve will not move left and right. That's why it's green. Okay. Although it can move on the y direction. So that's why we need dimension. And this time it's the reference is the x-axis. Okay, 1 inch. And next will be from x-axis to the center of the hole. Okay, and that'll be 1.13 inch. And it changes color, right? And from here, you can snap to x-axis or like this, 0.85. Okay, and something extra. P8, if you put dimension between those two holes, that means when you manufacture the parts, you're going to measure the center of those two holes and say, I want to make sure this is 0.85, no matter how other dimensions change. If you put a dimension from here to x-axis, and when you measure, you're going to measure from the center of the hole to the x-axis or to the center of this hole. And you're going to make sure the dimension is 1.98 for this, no matter how this hole changes. So that's what different types of dimension, even though they have the same results, that'll give you that'll show the design intention in your drafting. So they know I want to make sure this dimension is correct, and the others are less important. So you need to dimension properly for your drafting. Well, this is CAD, so at this stage it really doesn't matter that much. Okay, we have P14 here from this point to x-axis, and I have to turn this reference off. That'll be 2.6. Okay, and do we have any more? Okay, and here P13 is 3 inch. So from this point, alright, and we do have this P11's horizontal distance from the vertical line to this point, which is here to this point. That'll be 0.15 inch, and the length of this reference line doesn't matter. Then we can move down to the bottom of the handle, and as I said here, it's actually a curve. If you can't see, that's it's a little bit of curvature there, and it's tangent to this vertical reference line. That's why we need a line there. Okay, so how do we make this line? I said a 3-point arc, which is basically arc, and you have two options. First is 3-point. The second one is usually if you hover it, it's gonna show the name. So we're gonna just use that. 3-point starting point, point in the middle, or end point. So, and the way I do it, sometimes I just starting point, end point, then one in the middle. So here you can move your cursor left, right, and once you see it's tangent to this vertical line, and it'll actually highlight the vertical line, and click. That'll make sure this is tangent, and that short blue horizontal line is the tangent symbol. Alright, so, and there's your offset. Okay, we can do that a little bit later. We can add the bottom reference line first, and you want to make sure this line, the arc, touches the bottom line. So this circle means this end point of the arc is on the curve. Before, they are at the same spot, but there's no constraint, so if I move this line, it's not gonna stay. If we move this with a point on curve constraint, then it'll stay there. Okay, so turn that to reference. Then what's next? Next, we have a zoom in here for the bottom corner. Okay, so basically a straight line here. And you want to make sure to snap to this point instead of on the curve. So end point, go up a little bit, doesn't matter how much angle, because we're gonna add that later. Then pick this line, pick the arc, constraint, and yeah, it'll move. If you don't want that line to jump around, we can add this dimension P6 6.84 from x-axis, 6.84. Okay, and we have a distance for. Okay, that's a length. So sometimes if you use infer dimension, it's hard to get this distance. You can use parallel dimension for this kind of application because the angle is very close to horizontal, so it's very easy to get something like this. So you want to pull to the right side and 0.8. Well, I guess it's 0.08. Alright, and that's 50 degrees from horizontal, so 50. And that's all for this little corner here, and we have another dimension P12 is 0.36. So this arc, you would ask why we don't need a radius for that. We have this dimension to constrain the starting point, start point. Then we have this 0.36 to constrain the end point. And lastly, we have this length from x-axis minus this P10 is the length of this arc. So that'll constrain this arc, and that'll fully constrain this arc. Okay, now if I drag it, I don't think it'll move. Alright, and the offset. So we want to make sure the two sides of the handle has a constant distance between them, which is 0.45 here, and we can use a tool called offset and type in a number. I think by default is 5. Then if you click first, you're gonna have offset really big, so we can change that to 0.45, and even you're typing the number, it's not gonna change in the workspace. You have to hit enter, then it'll change. We can switch a direction, so it'll offset to the right side, and say OK. And as you can see, we have the offset symbol, and that's also offset constraint. Okay, and this point here is not this point. because once you offset, unless you cut it off, trim it, you can't really move this point, because the original copy is well, that's not good. The original copy is constrained in our case. Okay, so this error pretty much means I have to start over. Okay. Okay, we're back. We're gonna start from offset, then offset this curve 0.45 inch, the other direction. Okay, and say okay. Then what's next is this dimension, and let's trim this off first. Actually, you don't have to, because we're gonna use another method to extrude, so you can have sticking out like this. Okay, and then we have to close this loop. And by the way, this point is not the top point. Okay, so we're gonna use profile tool, and we have 1, 2, 3 straight lines. So click from the circle, point on curve, and 1, 2. The third one is on the curve. If it's forcing you to have a constraint, you can hold down Alt key, it'll kill the auto constraint on that. And I can overshoot and trim this off to make sure this one is a point on curve. Then we can add dimensions. We can start from the bottom. Okay, and you can tell from the color we have those 3 lines that's not constrained. And from the bottom to this point, I have to pick that point, is 2.9 inch, and we're gonna leave this one alone as your accumulate of tolerance. And okay, from x-axis to this point is actually what's here, 0.18. Okay, 1.18. Then from x-axis to this point is 2.7, and as you can see, those 3 are still not constrained, and we have an arrow here indicating this point can move left and right, and you can see there's a very mild dash line here. So that's actually a point on curve constraint. You want this point to align with the y-axis, so that's the point on curve. That's the dash line here, and still this point it can move. Okay, so we need a dimension. If you look at this point, we have this P19. From this point to the left side is 0.75. Okay, and they're all green now, and it says 3 constraints. I can tell you what 3. 1 is the length of this, 2 is the length of this line, and also the third one is the position of this line, okay, on the x direction. So for what we need, they're already fully constrained. Of course, what you can do is, you really hate that, you can extend that line. What about here? We can let's see, we can give it a dimension. Then you can even give it another dimension from this point to y-axis if you don't like on the constraint. So now the sketch is fully constrained. Okay, my sketch in the slides, it didn't have anything for the reference lines. Okay, so the sketch is finished. Next is extrude. Okay, and because this part is symmetric, so I'm gonna extrude symmetrically with respect to XY plane. So extrude and symmetric value. Okay, that'll be 5/16. And here, when we pick the section, pick the curve to extrude, uh, for our situation, we need to use a region boundary curve. Basically, that says pick area. Okay, and as you move your cursor, you can tell this method. So you don't have to worry about this thing sticking out. That's fine, because we're using different ways to pick curves or area. And okay, so that's the first extrude. And so next is a sketch, and I'm not gonna explain that much for the sketch. Okay, in the sketch now compared to the first sketch. So build a sketch on this plane. Okay, then notice the origin is not in the middle, because usually we want to put the origin at the symmetry plane or something. So you can turn this to inferred. It'll be a little bit easier to snap to the midpoint of this edge. And that'll be it. Then we're gonna start the sketch, which is this one. Okay, and you can use a profile tool. And if you look at the left side, we're going to cut this below the top surface. So basically, you're gonna start something like this. There's a step here, and this happens to be a point on the y-axis, which is on this edge. So you can snap to the edge and go horizontal. Then this point is flush with the top surface. Now we're snapping to the extrude or sketch 1 that we just made. So this, and go straight up, go back, and close this. The top side is actually not very important. All we care about this is the intersection of this sketch to the solid. That's the faces is going to cut off, going to cut the solid. Okay, so dimensions. 2" for total. You actually don't need that, as long as the left side is outside of the solid. But just for the sake of fully constrained, this is 0.62, and this length here is 0.35, and we have another length of this line, so the horizontal distance 0.7, and that's all for the horizontal dimensions. Then the vertical ones is first the distance from this line to the symmetry plane is 0.21. Then about this line to x-axis is 0.27. So 27, and I'm not gonna add the top. I have that there just to make it fully constrained. It doesn't matter this side because you're gonna use this bottom edge to cut. Okay, the top doesn't matter. So extrude, and we're gonna intersect. So we're gonna extrude the other way and intersect the first extrude. So here you're gonna pick subtract. Then we're going to subtract this value volume from the first extrude and say okay. Then that's the step here. Then next step is edge blend. Okay, what you can also do, you can do edge blend. You can also make fillets here. Well, it's hard to make a fillet here because you need to have a sketch going that way and make fillets. So I'll just use edge blend. Edge blend. So we have 4" for the top two edges. Okay. And you can say okay, finish this, or you can add another set just like your swept. with different radius. So those two are 0.4 inches. Okay, so we have 2 radius for different sets. That's why I have only 2 in the slides here. Next, we're gonna mirror this to the bottom, okay, to make the cut. And the mirror feature is insert, associative copy, mirror feature, and hold down control to select multiple features. Select a plane, that is XY plane. So there you go, this corner here. That's the bottom. Okay, and the next is cut off this triangle here, all because of this edge blend. Okay, this will not go over that. Well, you know what? I'm gonna show you why I have to use that. Okay, why I have to extrude this in the first place. So if you extrude something like this, and see how this edge blend stops right here, and it's gonna be a nightmare later. So I'll just extrude the whole thing, let this edge blend go all the way over, then extrude this triangle here. Okay, by the way, you have to change it to, sometimes you have to change to static wireframe to see through and pick things inside. And this is also symmetric because we when you subject both directions, and doesn't matter how long, as long as it's thicker than your first extrude, then you will have this cut here. Now we can hide the sketch, get a better view here. Okay, symmetric, yeah. Next, the edge blends. So here we have 3 individual edge blends, then the last one is a variable distance. So edge blend, this one you have to do this before the variable edge blend, because we're gonna pick this top edge, and when you pick edge to do edge blend, it's better to have a tangent edge, and here it's a straight corner, so we need to blend this too, and that radius is 0.8. Okay, we can also use that as a set trick. This is 5 inch, and this is another set, that'll be 0.2 inch, 0.2 inch, and okay. And for the radius of this, as long as this edge blend go all the way to the left side, you don't want to have a little bit left, and it's gonna interfere with that shell command, because shell command is sometimes it's picky. So you want a continuous all the way to the left side. Then the variable edge blend. So as you can see, we're picking up a tangent curve. So once you click here, it'll pick the whole edge, and you can pick both of them. You can also just do an edge blend on the top, then mirror feature to the bottom. That's what I'm going to do. So here I have 2 edges blended. Anyway, so if you have your radius on default 5, it's gonna show like this. Okay, don't panic. Just change that to smaller radius, and remember to hit enter. So it'll come back to normal. Then variable edge blend. So in this list, we can pick different locations where we want different radius. So first you need to move down here, then select the location. When you select a point at on those edges, because those are the end points, so I'm going to turn off the other snapping tool, just leave this end point on, then it's a little bit faster to pick. The first one is 1/8, 1/8. Then the second point of a different radius is on top of this bigger, thicker part. So from here it's gonna be 0.18. It's a little bit bigger blend. And also I want to keep this section 0.18. So I add another point to make sure between these points, these 2 points, is always 0.18, because the next point here, that'll be a bigger radius, which is half of the thickness, 5/16. So as you can see, we have a transition from 0.18 to 5/16. If you don't have this point, it's gonna go all the way to this point. And we don't need the end point, because after this last point, it's gonna be all the same radius. And we can say okay here. So as you can see, the edge blend just touch the symmetry plane. And next we can use mirror feature, save you some clicks. And plane is XY plane. So that'll give you this well, maybe the most difficult command in this part. Okay, next is the shell command. So it's on the top. We want to make sure that's okay. Default is on 0.25, and if you select it before you change, you will not see anything. You might see a little bit, but it's gonna be like that. And you will need to change to thickness, and it will not change in the workplace. You have to hit enter. So remember to hit enter every time you change a number. Okay, and it's gonna say something like this if you don't pick enough faces. So let's pick this, and it'll make it. So in the shell command, if you see alarm, I can't do that, I can't do that, just keep picking the faces. Okay, once you pick all the faces you need to, it'll make it through. Then for the cylinders, you can just keep clicking on them, it'll delete them. Okay, so that's the shell command. We're done here. And remember, the last 2 things we need to make are the edge blends. So we have 0.1 inch on the top, 0.5 inch here. That's 0.5, so 0.5. We can add another set for the back. This will be 0.1 inch, and as you can see, you have to hit enter to change or to make your number effective. And okay. So that's the whole process of making this part. And since our snip is symmetric, sort of symmetric, so you can reuse this handle for the other side. The only difference is on this side you have a hole there. So next time when we make the other part, the other side, we need to make a hole here. It's pretty simple, right? All right. Thank you for watching. I hope you can make this part easy and nice. Okay. Thank you very much.